Well, hola, everybody, and welcome back for some fun packed algebra here. We are going to move up to Chapter 7, Section 7 today. And what we're going to be looking at are adding and subtracting polynomials. So that's just a fancy expression or phrase for combining like terms, being able to add and subtract terms that are like. And in a nutshell, to be able to add or subtract any terms together, they need to have two things in common. First, they need to have the same variable. So what that means is I can only add terms like x's and x's. I have 2x and 3x will give me 5x. If I have 2x and 3y, they're disjoint, separate animals. I cannot put those two together. The other, in addition to being the same variable, x's x's, y's y's, b's b's, z's z's, whatever your letter that you're dealing with is, they also need to be raised to the same exponent, the same power. So I can't add like 2x squared and 3x to the fifth. They are both x's, but one is to the power of 2 and one is to the power of 5. So those would be unlike. I would not be able to add or subtract those. So let's take a look here. We have 7 kind of Nike just do it examples that we will go through, and then we'll look at a geometry connection in finding the perimeter of some two-dimensional figures. So example 1, I have a 2x squared, a positive 3x squared, and a positive x to the first. So I'm looking to see which terms are like, meaning which terms have the same variable, the same letter, that are raised to the same power. So I've got a 2x squared here. I can put with it this, yes, 3x squared, but this single x here is not like the first two because it is not raised to the power of 2. So what I have now, if I start with 2 and add 3, I am going to have 5x squared. Notice here I am not changing the exponent value. We only add exponents if we are multiplying terms together. Here it's addition. So if I have 2x squareds and 3x squareds, I add them together, I have now 5x squareds plus this single x to the power of 1. So that is my final result, 5x squared plus 1x. Again, these cannot be added even though they are both x's. This is an exponent of 2 and an exponent of 1, and terms need to have the same variable and exponent. So that's as far as I can go. Second term, I have a 4z squared. So I want to look and see, do I have any other z's to the second power? Nope. So 4z squared is my only z squared. Here I have a negative 8. I have another number, 2. So if I take negative 8 plus 2, that'll leave me with negative 6. Again, I'm always checking the sign, the positive or negative sign in front of each term. The 4z squared doesn't have a sign in front of it. That implies it's positive. The 8 is negative. 16z to the fourth is positive, and the 2 is positive. So then I'll end with 16z to the fourth. So that's my final expression. We'll talk later on about writing terms in standard form, where you have your highest exponent term first, down the line to the lowest, but we are just fine writing my final result as such. 3 is a little goofy. There's one like this on your assignment, so I thought I'd talk about it. Notice I start with a 5, b to the third, c, which is c to the first. Then I have a single b to the third, c to the first. So that's like I have one of them. And then I'm going to subtract 3 b to the third, c's to the first. So if you look at the 3 terms here, term 1, term 2, and term 3, they all have the same variables, bc, 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 raised to the same powers, 3, 1, 3, 1, 3, 1. So what I can do is just add the numerical number coefficients, values in front of the letters together to get my final tally. I start with 5 and add 1, that gives me 6. 6 take away 3 leaves me with 3b to the third, c to the first. That's as easy as it gets. All right, let's take a look here. The remaining 4 Nike examples are when I have terms in parentheses. Now, parentheses are just grouping terms together based on a specific reason. And whenever I have a plus sign in front of parentheses, I'm able to go ahead and drop those parentheses. Addition is the easiest way to go. That's like multiplying everything in here by 1, and 1 times itself, or 1 times anything is itself. Okay, so I've got a positive 2x squared minus x, so I'm dropping the parentheses. And then since I have addition, I can also drop the second parentheses. So plus x squared plus 3x, and then minus 1. Okay, now I'm going to look to put those like terms together. I've got a 2x squared, no x squared here. Oh, here's another x squared, that's 1x squared. So if I have 2 and 1, that'll give me 3x squared. I've got a negative x to the first and a 3x to the first. Again, looking at the sign in front of the term. So I've got a 3 here and a negative 1 there. So 3 and negative 1 gives me 2. And then minus 1. So there is my final expression. Again, putting all like terms together, terms that have the same variable and exponent. Example 5 is another addition example, so I'm able to drop the parentheses. 5a to the third, 3a squared, minus 6a plus 12a squared, and then plus 7a cubed minus 10a. All right, so like terms here, I have a 5a cubed, and then here's another a cubed. I've got 7, so 5 and 7 gives me 12a cubed. Moving down the line, I've got a squared. I've got positive 3 and positive 12. So 3 and 12 will give me 15a squared. And then finally, negative 6a minus 10a. So be careful on that sign. Negative 6 minus 10 gives me negative 16a. And there we have it. Let's talk about subtraction. These you have to be really careful on your signage. Notice your first 2 parentheses don't have a minus sign in front of it, so you can drop the parentheses on the first group. But when I have a minus sign in front of parentheses, I need to take that minus sign to all terms in the second group. So minus 3a to the fourth. And then I've got minus negative 3a becomes plus 3a. And then minus 1 is just minus 1. So I've got 1a to the fourth, take away 3. 1 minus 3 is negative 2a to the fourth. Here I have a to the first, negative 2 of them, and 3 a's to the first. So negative 2 and 3, 3 minus 2 is just 1a. And then numerically I've got minus 1. So that is my final expression, combining all of my like terms. So again, we'll illustrate here. There's no sign in front of the first group, so I can drop the parentheses. Negative 7h squared minus 4h plus 7. And then the minus sign in front of the second group of terms, in front of that second parenthesis set, needs to be distributed to all 3 terms. So minus 7h squared minus a negative becomes plus 4h, and then minus 11. So like terms, I've got negative 7h squared minus 7h squared, so negative 7 minus 7 is negative 14h squared. Then check this out. I've got negative 4h plus 4h. Negative 4 plus 4 makes 0 h's, so I don't need to write anything if I have none. And then numerically, I've got positive 7 minus 11. 7 minus 11 is negative 4. So there we have it. Those are your Nike just kind of do it examples of putting your like terms together. Last set of examples here deal with finding the perimeter of a figure. Again, perimeter is when you take the sum of all outside side lengths. So question 1, I have a rectangle as indicated by the 4 right angles. So I've got a top of 2x minus 7 plus a right side of x plus 2 plus bottom side, top and bottom will be congruent, so I'll have another 2x minus 7 plus my left side will be congruent to the right side, x plus 2. So when I combine the like terms, I have 2x, 1x, 2x, 1x. 2 and 1 is 3, 4, 5, 6 x's. And then numerically, I've got negative 7 plus 2, negative 7 plus 2. Negative 7 and 2 is negative 5, and another negative 5 will give me 6x minus 10 units. And then for a triangle, process is exactly the same. Here, instead of adding 4 sides together, a triangle has 3. So I'll take the left side, 2x, plus the base here, x minus 3, plus the diagonal side, 3x plus 1. And my like terms, I'll have 2x, 1x, 3x. So I've got 2, 3, 4, 5, 6 x's. And then numerically, I have negative 3 plus 1. Negative 3 plus 1 is negative 2. So 6x minus 2 units there. There we have it. Have a little fun putting some like terms together and have a sweet day.